All right. Let's start going over this. Okay. We're going to go over that in a second. Hold on. At least I'm going to launch that before we wrap up today. So, a lot of us started making a table, and I think that's a great thing, especially on the calculator. And I will say, I think eventually everyone got to the same equation here. Y equals what?
4n plus 4.
So 4n plus 4 or 4x plus 4. I saw 4 plus 4x, which is just a backwards version. And then y'all defined your variables differently of n equals 4d, or 4 plus 4d, I think is what y'all did. So be careful. The one thing I will say is, and I told group 3 this, if you were to use n this way, what they were meaning is the total number of tiles around the outside, right? Which makes sense, but I had interpreted number 2 for n to mean something different, which is why you need to always do what with your variables? Define them. As long as you define your variables, I'm good. So if you say d is the design number, and you write out that n is the total number of tiles around the outside border, I'm good. Personally, I would have done something like b is equal to 4 plus 4d for the border is equal to 4 plus 4 times the design number. Or t is equal to 4 plus 4d, where t is the number of tiles. So there's any way that you want to do this. They're all saying the same thing. We just need to be careful about defining the variables. I do want to point this out. Some of us made our lives way harder than it had to be. Let's go to class. Jada, I'm putting your calculator up real quick. So Jada went ahead and created variables. She created a table. She could continue this table, correct? What can she do to use the calculator to make sure she gets the equation, though?
Ooh, the top one, put in the,
What thing?
you know what I'm talking about.
I don't know what you're talking about.
Well, see, I know what I'm talking about.
The regression shows what.
Can we use the calculator to do a regression? Yeah. Jada, and don't forget, you can make a data and statistics page, but can't you also do a regression on this page? Yes, you definitely can. Jada, can you hit menu for us? Where would I go from menu to do a regression? Statistics,
How do I make a new?
stat calculations,
How do I make a new?
and there's your linear regression. Now, before you click anything, hit escape real quick for me, Jada, and go back to that point. I want you all to notice there are 2 different equations for a linear regression. mx plus b, which is what you're used to, but there's also the a plus bx that we see right here of 4 plus 4d, right? Either one is completely fine. Okay, so Jada, can you go to the mx plus b? Number 3, there we go. And so what does her x variable need to be? Design, y variable? Tiles. And then just create that, run that regression for us. Yeah, see, there we go. All right, let me erase it. I want you to notice, what does it say our slope is? What does it say our y-intercept is? Hey, also look at what our r is. 1, which means that that data is a perfect what? Perfect line. Remember, the closer it is to a 1 or negative 1, the more, and it's not just a strong linear relation. When it's a 1, it's perfect. Okay? The closer you get to 1, the better. So notice we have our slope and our y-intercept right away from the calculator. The calculator can do that for us. All right? Don't forget to use the power of the calculators. Moving back from there.
Hey, how do you do that in the first place?
All right? So we wrote that expression. We have several different expressions that we can do there. Don't forget, like, the key was identifying. So some of us forgot to do this right away, but the key was identifying the rate of change, the pattern, because what does that rate of change define? What does that rate of change define? The type of function. Once you knew it was linear, what's the equation we're using? Y equals mx plus b. That's it. Once you use linear, we're using y equals mx plus b. There are other equations, but That's the only ones we're going to consider for now because we want to focus on quadratics. Looking at number 3, describe which values for n make sense in this problem.
All positive values plugged in at n will keep our equation linear,
Okay?
but if it's a negative, then you can't exactly have negative amounts of tiles.
Okay, so I will point out, you can substitute a negative number in. It'll still stay linear, but can you have a negative number of tiles?
So
No.
we have to take the context of the problem.
Correct. Yep. All positive values for n. And again, and this is the only reason group 3 why I was saying be careful about how you define your variables, because they're using n as an input, whereas y'all used n as your output, right? So you might need to say d here instead of n, right? So all positive values for, I'll say inputs, makes sense. I feel like we need to add a little bit more to that here. Okay, so no part of a design. It's either design 1, or it's design 2, or it's design 3. So all positive values for inputs that are also whole numbers.
I mean, would it stay linear? It would just have like a point that was like, okay, can I ask the question, but I'll like kind of show you what's it. Okay. So if you have these points right here, and then somebody were to put a decimal, like,
Well,
technically it would be linear, but it's
it would
like
still
random.
be, yeah.
Our additive rate of change would be off.
Well, no, it would still be linear. It'd still be on the point. It just, or it'd be on the line. It just wouldn't make sense because you're not going to have 4.5 tiles.
Yeah.
It would still be the same slope.
But if it
But
wasn't,
it would still be the same rate of change. That would be the same up, or rise and run. It's just in between.
yeah, that's what I'm saying, but if it wasn't tiles and we could do that, even though it's a, oh, okay, that makes sense. If it wasn't tiles, that would make sense. Got it.
So, I don't care about this one. This is not a great question based on the way we redesigned this. So here's what we're going to get into tomorrow, and this is something I do want you to very clearly see, is there's actually going to be multiple ways to write this equation. You wrote it as y equals 4x plus 4 because that was the slope-intercept form of the line, correct? But if I'm looking at these pictures, where do we see this plus 4, this y-intercept? That needs to be something that's constant. Is there anything in these designs that's staying the same every single time?
Middle, if we had to change that.
But we are changing the middle, right? So notice, you see how these middles are changing? Right here? What is staying the same?
The outside.
When you say the outside, you mean the, you see how those corners? How many corners are there?
4.
Oh. So why is there a plus 4? Because those corners are not changing. Those corners are always there. So where do we see the 4 times x? Where do we see that repeated addition of 4? Well, in design, remember we redefined these. No, we still have 2 minutes. Chill out. When we had to design 2, how many were in the middle on each of these? Like how many would be right here? 2. So 2, 2, 2, and 2. So we have 4 groups of 2 each. Here we had 4 groups of 1. Here we had 4 groups of 3. That'd be 3, yeah, for design 3. So for design 4, we'd have 4 groups of 4. So please notice there are actually multiple ways to look at each of these based on the picture. And so what we're going to look at tomorrow is equivalent expressions that are designed based on the picture that's shown there. Not tomorrow, because we won't be meeting tomorrow. Study for your 9 weeks exam. That's your homework. Finish your 3 linear and exponential practice. Hey, y'all, please stop and listen. All the talking needs to stop. Okay? Leave your textbooks on the desk. Make sure the calculator's up in a second. But what I need you to hear very clearly on is, I am going to be sending out a solution set for the test that I created so that you can see what I would do. I will go in and add a couple extra details based on the things I saw us struggling with. I'm gonna do the same thing with the review homework. Use your resources to be successful. I will be here after school tomorrow, and I'll even be here after lunch if you want to come in to ask for help before the end of the school day. Take advantage of your resources, use the videos, do something to make sure you're learning what you need to do. Leave the textbook if you borrowed the textbook, sorry. Leave the textbook if you borrowed the textbook. If you didn't borrow it, take it home.
So for this one,
Yeah.
I'm saying like tile, T.
Why did you do three
That's
extra?
what I was saying, the four I get the one of
How many groups of three are there? Right, so it'd be four. That's why she has it as 4 times 3, because she had 4 groups of 3.
Okay, so it's like, equal the amount of size, so that, would that change then?
What?
Like the four, like if we were.
How many
doing
sides are there
80 box.
always?
Yeah.
Okay, the X is how many are inside the middle here, and there's plus 4 there, right?
And then I have one trying 15.
Yeah.
DJ had to answer me, and I feel like he knows this better than I do,
I mean, what's your y-intercept? Right, so because notice we're multiplying by 1/3. 3 times 1/3 is 1, so that should be a 1 there. Well, what is,
Oh, yeah, sorry. 3 1/3 of the time.
well, then notice what's 3 times 1? And 3 divided by 3 is 1.
Right, and then, so it'd be 1 times 1 over 3.
So we're starting at a y-intercept of 1. We're repeatedly multiplying by 1/3. So that is raised to the x.
Right? Okay, and then the other one was, there's one here.
I would
This one. He had 10 times -7.
What's your rate of change again?
Next.
Are you multiplying? Yes, ma'am.
I was trying to see can I come back beginning third.
For what? To ask a question about this? Sure. Who's your third block teacher? Can you write it up on the board so I remember? Thanks.
I was like, so, I think we're jumping on -7.
And notice how you just said add.
I mean,
Well, it's subtracting, but it's adding or subtracting, so why are you multiplying? Why do you have an exponent?
the exponent is because we don't know how many times.
But an exponent is repeated, right, are you multiplying here?
So does it need to be?
So you could say, hey, I'm starting at -18 and then I'm subtracting. Aren't you actually no, hold on, that's not right. So remember, you're subtracting 7 going this way, so what would you do going the other way? So that would be 3.
I would go and swap it, and then 10.
So 1 would be 3,
So
0,
you're right.
2.
I knew.
So it'd be starting at 10, but then again, like we're subtracting 7 x number of times. Or you can just say, hey, my slope is 7 and my y-intercept is 10. Okay?